So let's try this again. Let's write down what we mean by differentiability. So f of x and y is differentiable at AB. Okay, so here's my point, AB, down here. Right, that's a domain point. And then I've got my function f, which in this case is this black handkerchief here. Right? That's f of x and y. Cool. And then here's my tangent plane. That's the blue thing. Oops, I should probably call this L, x and y, right? And that's built around this point AB, so that it's tangent at AB. Cool? Okay, and now what I'm going to mean by differentiability is, right, is this a good approximation? So I'm going to take a point on the linearization, right, and a corresponding point underneath it on the handkerchief. And that's going to be really over the top of some point in the domain, right? You see that? So I want to know, as this thing gets closer to AB, does that approximation get better? You see that? So I'm going to figure out how far that thing is from AB by going, okay, it's this far in one direction and this far in the other. What would you call those? You'd call those probably delta x and y, right? So I'm going to call this one delta y, this one delta x. You see that? So what I'm going to say is I'm going to say it's differentiable if the limit of delta x going to 0 and delta y going to 0. Right? So squeezing that thing in on both directions of what? Let's see, I want to take f at that point. So what's that point?
AB.
That's so where's the black dot? How high is the black dot?
Black is f of AB.
It's close. So this dot's at f of AB, right? This little x dot that's on the handkerchief a little bit off of there is f of a plus delta x, comma b plus delta y. And I want to know how far is that from the linearization, right? So then I'm going to subtract the linearization, right? And that linearization is built around AB, but where am I going to evaluate it? At the same point, right? A plus delta x and b plus delta y. And then I want to know, does this thing go to 0 faster than my distance goes to 0? So how far is this point? A plus delta x and b plus delta y. How far is that from AB? Perfect. Right, the square root of the radius squared. You guys see that? Okay, so this says, right, the distance between the function and the linearization goes to 0 faster than just walking in along the radius. Cool. And I want this to equal 0, so I'm saying it happens faster.
If it didn't, then it would go to infinity.
Even if it went to something else, this would be a bad linearization, because it would say that there was some, like, hey, if you just walk in, you're getting to this function value faster than the linearization's getting there. That seems like your function wasn't locally linear.
When you say the distance, you mean the distance between them?
Yeah, so when I say the distance, I mean this is the top of that thing, right? Right, that's this distance on the top. And on the bottom, I actually have a radial distance in the domain. You guys see that? So that's the distance in the inputs, or sorry, the distance in the outputs comes together faster than the difference in the inputs.
Okay.